The science of irrigation has made considerable progress over the past 50 years and has made a significant contribution to production increases and higher quality crops. But these gains cannot be achieved by accident or by guesswork. What you're about to see will help you better understand the science of proper irrigation management and how Irrometers can assist you in producing better crops while at the same time eliminating water waste due to over-irrigation. Whether on the ground, in an airplane, or from space, we can quickly see the evidence of the mark which water used for irrigation makes on the face of the earth. Water is our most precious resource, the elixir of life, but it is becoming limited in quantity and must be used correctly. Proper irrigation management, besides enhancing crop production, leads to a progressive program of water conservation and the protection of water quality by eliminating the excessive leaching of farm chemicals and nutrients into the groundwater supply. In the arid growing areas, irrigation is a necessity for any economic farm production. While in the humid growing areas, it has been demonstrated that irrigation is economically justified as an insurance policy. To provide for bumper crops when rainfall is untimely or during periodic droughts. Readily available soil water is the most essential crop nutrient, and crop yields are directly related to the proper timing and amount of irrigation applications. Soils which are kept too wet are deficient in oxygen, which is essential for healthy root development. These waterlogged soils also become breeding grounds for soil and waterborne diseases and usually result in significant economic loss. When soils are allowed to become too dry, the crop will be unable to secure the moisture necessary to sustain the desired vegetative and reproductive growth. Proper irrigation management must achieve a balance of air and moisture in the soil, or put more simply, the irrigation manager must answer the two age-old questions of when do I irrigate and how much water should I apply. The key factors which affect the answers to these questions are the sun, temperature, wind, humidity, crop root system, type of crop, and the type of soil. To know the precise effect of these factors on the crop being grown allows the irrigation manager to properly schedule his irrigations. The most accurate method of scheduling irrigations, proven over several decades, is achieved by the use of Irrometers to provide for the direct sensing of actual soil moisture. It costs only pennies per acre, and Irrometers are easily used and understood by individual growers. An Irrometer is a tensiometer. It is a hollow, water-filled tube with a porous ceramic sensing tip at one end and a vacuum gauge at the other. It is sealed at the top by means of a cap and stopper assembly. Irrometers are installed directly in the root system of the crop. A shorter instrument monitors the shallow root system and tells a grower when he needs to start irrigation. A longer instrument monitors the deep root system and evaluates water penetration to prevent over-irrigation and excessive leaching of plant nutrients. The questions of when to irrigate and how long to run are thus answered by the use of Irrometers. Irrometers measure a property of soil water known as suction or tension. This is the force by which water is held in the soil, and it must be overcome by the crop root system in its process of extracting water from the soil. As soil dries, suction or tension increases and pulls small quantities of water out of the Irrometer tube through the porous sensing tip. This creates a partial vacuum inside the tube, which causes the reading on the vacuum gauge to increase. The drier the soil, the higher the reading. An irrigation or rainfall, if it is adequate, causes this action to be reversed. Thus, the Irrometers directly and accurately show the grower what the crop root system is experiencing in its quest for water. They are often called dummy roots. Waterlogged soils are shown by readings below 10 centibars, while soils which are becoming dangerously dry are indicated by readings over 60 centibars. Because Irrometers are unaffected by soil type, salinity, or fertilizer salts, there is no need for the calibration or interpretation of the data, as is the case with other methods of soil moisture measurement. Tensiometers have been used since the 1920s in agricultural research and are still the basic tools by which plant scientists eliminate irrigation as a variable in their experiments. They are used in the laboratory in growth chambers and in field plots. Irrometers are used with all methods of irrigation. In basin or flood irrigation, Irrometers are generally placed up on the border. Use slightly longer instruments than normal and angle the tips out into the area flooded by the irrigation cycle and in the root system of the tree. In furrow irrigation, place the Irrometers up in the row between plants, not in the furrow. About 2/3 down the run is usually the best spot since water penetration is usually the poorest at this point. In sprinkler irrigation, make sure that the Irrometers are located so that they can see the sprinkler. That is, so that there are no obstructions like tree trunks or limbs which can interfere with the even distribution of water to the Irrometer area. In drip or trickle irrigation, locate the Irrometers 12 inches to 18 inches away from an emitter. With micro sprinklers, place them 2 to 3 feet from the sprinkler. Take care to make sure the tips are in the active root system. If you get too close to an emitter or micro sprinkler, your readings could be false on the wet side, or if too distant, they could be false on the dry side. Any number of additional instruments can be located at any distance from an emitter to monitor subsurface water movement, but the controlling instrument should be 12 inches to 18 inches from an emitter. It is also a good idea in drip irrigation, particularly on the deeper-rooted crops, to use 3 instruments at each location. Monitoring the moisture at 12 inches, 24 inches, and 36-inch depths will give you much greater control over the management of your drip system. A typical success story from the use of Irrometers in tree crops comes from a grower in Southern California, Topham & Sons in Riverside. In 1957, they began development of 1,500 acres near Lake Matthews on soils which many believed to be too shallow for a successful citrus planting. They planted 150 to 200 acres per year with Irrometers installed at the root ball of an indicator tree every 2 to 3 acres. Irrigation was done with contour furrow and dragline sprinkler, but since has been converted to drip irrigation. Comparing water usage between the Irrometer-controlled blocks and similar blocks using the calendar method of scheduling showed a savings of nearly 2 acre-feet of water. In 1965 dollars, this savings was $58.20 per acre, or nearly 15% of the cost of cultural operations. Today, that 2 acre-feet of water is priced at $500 or more. But the real bonus came in the production achieved. The original planting of Washington navels has been the most consistent producer over the years, with average production for the period 1963 through 1972 being 600 and 500 boxes for the 2 rootstocks used. In 1973, after 15 years of intelligent management, this planting was tops in the packing house and produced 900 and 750 boxes for the 2 respective rootstocks. In the early 90s, the navel blocks still averaged 1,000 boxes. Vegetable crops have long benefited from good irrigation management, since these crops are extremely sensitive to any moisture stress. Here we see pole tomatoes being irrigated with subsurface drip irrigation using Irrometers placed directly in the row between plants. Whether asparagus, carrots, or strawberries, good irrigation management is a must to achieve top quality and yield. The Idaho russet potato is famous for its quality, but the key factor is good water management. Stukenholtz Laboratories is one of Idaho's leading crop consultants and utilizes Irrometers to schedule irrigations on literally thousands of acres spread out over the prime growing areas of the Snake River Valley. Growers who utilize the management services of Stukenholtz Laboratories consistently better the state average by 25 to 50 sacks per acre. Irrigated corn producers in South Dakota and South Carolina have benefited greatly from good water management utilizing Irrometers to guide them. Consistent yields of 185 to 215 bushels have been achieved by irrigated corn producers in both of these states. Irrometers were used by all of the top producers to schedule irrigations. The first step in properly utilizing your Irrometers is to determine the location of moisture sensing stations and the number of stations necessary to do the job properly. The factors to consider are soil type, topography, sun exposure, and the size of the irrigation block. An example of very intensive monitoring is found on hillside plantings. Here we have variations in soil type, major topography changes, and perhaps the situation of both north and south-facing slopes which have different sun exposure. In this case, you may have to monitor every 2 to 3 acres to get an accurate picture of soil moisture. However, where soils are more uniform, terrain is level, and the irrigation blocks much larger, monitoring every 15 to 20 acres is usually adequate. The basic rule, however, is to use more instruments in a smaller area to begin with, and then to move them out to encompass a larger area as a pattern of uniformity develops. After you have selected your locations, it is now time to install your Irrometers. Use a piece of half-inch galvanized pipe or 7/8 solid rod to make a hole in the soil to the exact depth as required by the length of instrument to be installed. Various crops have different rooting depths, and we can always advise you of the correct lengths to use based on your crop, soils, and method of irrigation. Be sure to locate your access holes so that the tip of the Irrometer is directly in the root system of the crop being monitored. After you have finished preparing the access holes, it's now time to fill your Irrometer with field solution. Irrometer field solution is simply good clean water, preferably distilled, which has been colored green for high visibility. In the Irrometer service kit, there is a 1-ounce bottle of Irrometer fluid concentrate. Use 1/2 capful to a gallon of water to give it the green color. Fill your Irrometers completely full, including about 2/3 of the reservoir. Since the field solution is highly visible, it is easy to see when you have filled them completely full. If an airlock develops in the filler hole, tap the top of the reservoir with the palm of your hand, which allows the fluid to flow into the tube. Replace the cap and your Irrometers are ready to be inserted in the access holes. Begin by removing the protective tip bag from the Irrometer before installation. Insert the Irrometer into the access hole and make sure the instrument bottoms out and fits snugly. You can bear down on the top of the cap, not the gauge, being careful not to use any side levering action which could break the tip. Leave at least 1 inch between the bottom of the gauge and the soil surface to allow operation of the gauge diaphragm. This eliminates distortion of the gauge readings caused by heat building inside the sealed gauge. Repeat the installation procedure until all instruments are installed. It is now time to de-air the instruments for accuracy and sensitivity. Remove the instrument caps and place the suction cup of the hand vacuum pump over the top of the reservoir. Give 4 to 5 quick pulls on the handle of the vacuum pump. This will cause a reading on the gauge of 80 to 85 centibars and result in the entrapped air being pulled out. Leave the vacuum on for 10 to 15 seconds to allow the entrapped air to rise to the top. Tapping the top of the instrument with the cap helps the air rise more rapidly. Remove the vacuum slowly by pushing gently on the finger release valve mounted on the side of the suction cup. This prevents any damage to the gauge which could occur if the vacuum is released suddenly. Repeat this de-airing procedure 2 to 3 times at the beginning and then every 45 to 60 days during the irrigation season. This assures that your instruments are at the peak of accuracy and sensitivity. One further precaution worth noting is that de-airing is best done after irrigation when the soil is moist. If you de-air instruments in dry soil, you will actually pull soil air into the instrument through the porous sensing tip, defeating the de-airing process. Replace the caps, being careful not to over-tighten them. About 1/4 turn after you feel the stopper bottom out is all that is necessary to seal the instrument. Over-tightening can damage the cap and cause the stoppers to fail prematurely. Your Irrometers are now ready to use. A new soil moisture sensor technology is the Watermark Sensor. This sensor measures the soil water status indirectly by measuring the electrical resistance between 2 electrodes located at the top of the sensor. The Watermark sensors are read by using a handheld portable meter. They are installed in the soil, in the root system of the crop being monitored, just like an Irrometer. To prepare watermarks for installation, soak the sensors for a few hours in a clean container of water. If time permits, removing the sensors from the water and allowing them to air dry for 1.5 to 2 days helps improve initial sensor response. But just prior to installing, re-soak the watermarks, as you always need to install a wet sensor. As with an Irrometer, use a piece of 7/8 rod to make an access hole in the soil to the depth required for the specific crop being monitored. In very coarse or gravelly soils, you may want to make an oversized hole 1 inch to 1 1/4 in diameter. This prevents abrasion damage to the sensor membrane from sharp soil particles. Watermarks installed in oversized holes need to be grouted in for a snug fit. Use a piece of 1/2-inch class 315 PVC pipe with the sensor lead wires running up through the tube to push the sensor down to the bottom of the access hole to assure that the sensor has bottomed out. You then remove the PVC pipe and backfill the access hole completely. If you wish to have a little nicer looking installation, the 1/2-inch class 315 PVC pipe can be solvent welded to the sensor collar using an ABS to PVC cement. IPS Weldon PVC cement number 974 is a good choice. This arrangement is particularly useful for annual crops where you will want to remove the sensors prior to harvest. Usually it takes one dry down and then an irrigation cycle for the sensors to settle in, after which time you can begin taking and recording the readings you get with your Watermark meter. The Watermark sensor is an improved gypsum block, which overcomes the principal disadvantages of regular gypsum blocks. The most important factor is the fact that the Watermark covers the wet end of the soil-water range, down to 10 centibars, and then on up to nearly 200 centibars, which is getting too dry for best production in most cases. However, in the 10 to 20 centibar range, it is not nearly as sensitive as the Irrometer. The Watermark does have the internal gypsum buffer, which serves to compensate the reading for the effect of the salinity levels found in most agricultural situations. This internal gypsum means that the Watermark does not dissolve in the soil like a gypsum block, although the exact life of a Watermark can vary depending on the individual circumstances. Sensors that are 6 to 7 years old have been known to be completely functional. In freezing climates, Watermarks can be left in the ground over the winter because they have been found to be basically unaffected by freezing temperatures. They will go off scale when they freeze, but when they thaw out, they will resume operation. Finally, because they are electronic-type sensors, they can be easily interfaced with electronic data logging and control equipment. A comparison between Irrometer tensiometers and the Watermark is shown here from some work done on potatoes in Idaho in 1989. This data shows the close correlation between the readings. Although the Watermark readings tend to lag behind the tensiometers, notice July 5th where the Watermark read 30 and the Irrometer read 52. The Watermark tracked the Irrometer very closely. In selecting whether the Irrometer or Watermark sensors are best for your particular use, the things to consider are soil type, method of irrigation, sensitivity of crop to moisture stress. This selection guide will help you in making the correct choice. At the top of this chart, we'll consider both the method of irrigation, drip, sprinkler and surface, or furrow, and sensitivity of the crop to soil moisture stress. On the left side of the chart, you will see the various soil types, from coarse, light soils that dry quickly to heavy soils which dry slowly. As an example, suppose you have light soils with a drip irrigation system used to irrigate a water-sensitive crop. In this case, because you really need to irrigate at fairly low soil suction readings, such as the 10 to 20 centibar range, the Irrometer would be the best choice. This is because the Irrometer is so sensitive and accurate, especially at the lower readings. But if you had heavy soils with a furrow irrigation system used to irrigate a more drought-tolerant crop like cotton, the Watermark would be the best choice. In this case, you'd perhaps not irrigate until readings reach the 80 to 100 centibar range, which is beyond what an Irrometer can measure. For situations in between these two extremes, you would perhaps be able to actually have a choice between the Irrometer and Watermark. Such would be the case in a medium-type soil with a center pivot mechanical sprinkler on potatoes or corn. The economics of the situation and how many sensors you actually need might cause you to choose the Watermark over the Irrometer or vice versa. In any event, these guidelines will help you make the best choice for your own particular situation. Whichever sensor you choose, Irrometer or Watermark, the cornerstone of the Irrometer Irrigation Management System is the periodic reading of your Irrometers or Watermarks and recording the data on the charts which are found in the Irrometer service unit, or which can be purchased separately. This charting of the readings gives you a very vivid picture of your soil moisture status, and more importantly, how fast is the soil becoming depleted on available soil moisture. As your soil water becomes depleted, the curve rises, and after irrigation, the curve will decline. This chart also clearly shows whether you need to run a short irrigation to replace shallow moisture or a longer irrigation to replace deep moisture. The white line on this chart is very typical of the type of curve you will expect with a surface or sprinkler system. Irrigations are withheld until your readings are in the 30 to 60 centibar range. You water less often, but you quickly replenish the soil water reservoir. The yellow line on this chart is typical for drip or micro irrigation. Here you start irrigation in the 15 to 25 centibar range. You irrigate much more frequently, but in much smaller amounts. With micro-irrigation, never let readings get beyond 35 to 40. If this happens, you run the risk of getting behind and never being able to catch up. A classic example of using the charts comes from an avocado grower utilizing an under-tree sprinkler system. He successfully uses the charts to determine when to irrigate as well as how much water to apply. In the case of this sample chart, Irrometers were used to monitor two depths, 12 inches and 24 inches. The Irrometers were read 2 to 3 times between irrigations with the readings plotted onto the chart. As this chart shows, shorter duration irrigations of 4 hours were applied when the 12-inch reading went beyond 40 centibars. This was adequate to re-wet only the top 12 inches of the soil reservoir where most of the water is used. But when the reading on the deeper 24-inch instrument went up to beyond 40, he increased his irrigation cycle to 7 hours. This restored the deep moisture. You will note that the deep irrigation was only necessary every second or third irrigation, and it resulted in the maximum water savings and minimal leaching of nutrients, plus providing the trees with a happy home of readily available soil moisture. Thus, your Irrometers or Watermarks are only as good as you choose them to be. Making it a habit to read your instruments and record your readings is simply good management, and it always pays you a big dividend in return for your effort. Regardless of what crops you grow or the method by which you irrigate, the future course is clear. The modern grower of today and of the future cannot afford to risk anything but top yields and quality. Nor can he afford to waste any water, energy, or fertilizer if he expects to be profitable. Since 1951, Irrometer Company has worked to help you better manage your irrigation and to help you conserve our most precious resource, water. Isn't it about time you turn to Irrometer Company for true irrigation management? Irrometer Company, technology for the 21st century and for a sound environment. Why not ask us today?